This is the art of network engineering, where technology meets the human side of IT. Whether you're scaling networks, solving problems, or shaping your career, we've got the insights, stories, and tips to keep you ahead in the ever-evolving world of networking.
Welcome to the Art of Network Engineering podcast. My name is Andy Laptop, and I am your co-host. I am your host, your co-host. And my job here is to try to use the power of communication to tell a story, right? Some stories are so profound. Some stories are so inspiring. Words fall short. So I'm going to try a different intro here. And if you'll indulge me for 90 seconds, I'm going to see if this works. And we're just going to watch something. And then when we're done watching this, I'm going to introduce our guest and ask her what this was like.
New Glenn is ready for launch of Blue Ring Pathfinder.
This is our first flight, and our key objective today is to reach orbit safely.
GS1 at flight level. Good water start. 3 ignition, 2, 1. Lift off.
All 7 engines at full thrust. Checking for pressures are good. Vehicles cleared the tower. Now passing 18 seconds into flight.
Separation confirmed.
And we have ignition on both D3Us. Chamber pressure is good. GS2 is now orbital.
We've got to orbit safely. Congratulations, Blue Origin. Y'all have gone orbital.
Ladies and gentlemen, Lexi Cooper, what was it like watching your network go to space?
It was surreal. I'm going to be completely honest. That particular night, we had already scrubbed once, right? Before that, a day or two before that. And then that particular night, I was like, oh, we're probably going to scrub again. I don't really expect, And so I was live streaming with a friend, believe it or not, on Twitch. We were just hanging out, talking about cybersecurity and networking. And we were just like, oh, we'll hang out and watch it. And then when I realized, like, oh, shit, it's going to go. I was like, hey, Tibbs, his name is Tiberius. I had to go. I was like, I'm leaving. And I left the stream live and just went to watch it on the big screen with my partner. And I cried like a baby. It was surreal, dude. I'm very proud. I'm still very proud of that. It was quite a night.
You've been on a bunch of shows. You've been a host on the Art of Network Engineering. I heard you on Packet Pushers. I think you've told your story enough times, so we can touch on it if we want. But for people living under a rock who don't know you, I mean, you hated your old career and jobs. You moved back home. You went to community college. You discovered network engineering. You got the bug, which is my favorite part of every story. Mm-hmm. That part when somebody's like, oh my God, this is how it works. Like, holy shit. You got a job at an incredible knock at the IBM cloud place. And then somebody saw you on Twitter at Blue, right? And saw your thing. And
pure luck. Absolute pure luck. I'm so lucky that happened. Yeah. Somebody just saw me on Twitter. So,
but you were live streaming, I think a little bit of research. I listened to your Packet Pushers episode today, and I remember you mentioning that I think you're live streaming, you're studying.
The most boring thing a person could live stream is studying for the CCNP.
I watched
Could you imagine?
But I watched them. I used to love watching your stuff. I loved watching you yell at Cisco Press. It was my favorite thing in the world because it's what
I have heard that's cathartic. Yeah.
It's what I've been every time I read those books, it's what I've thought forever. Like, oh my God, the grammar, and oh my God, the you're still talking about the illustration 15 pages back. I got to look at, like, you people are driving me crazy. So listening to you do it on the streams, I'm like, yes, give us a voice, but I guess they discovered you kind of there. Was that part?
Yeah, I've finally cleared it up because it's my mentor now at work. Like, I've been working with him ever since, right? And like, I finally, talked to him about the full story because I listened to him tell someone else. This is the person who brought me in.
How did he find you?
So he was, as he tells it, he was actually. This is so old school. I love it. He was on IRC like message board, right? And someone else actually saw my Twitter posts and posted that to the IRC, and
That's
that is
awesome.
how he found me. So just very legit. Yeah, so that's how he found me. He basically, I think he tells it like, yeah, I saw like you were like shit posting about BGP and how annoyed you were with it. And I thought, yeah, this person probably needs to know some stuff about BGP to be complaining about it this much. So then, you know, he messaged me on Twitter and was like, hey, if you're interested, because I had the NASA thing in my profile, he's like, hey, if you're interested in working in aerospace as a network engineer, here's some stuff you can look into. And I was like, whoa, that's cool. Thanks for letting me know. We had a little conversation. Then a month or two later, they had an opening for a network engineer, and he approached me and was like, hey, you should apply.
And you mentioned you didn't think you were going to get the job. You're like, this is ridiculous.
No. And I actually told them, I did a first round interview with them of just like sort of a general, not really super technical, just a general talk with him and my, you know, potential future manager. And afterwards, you know, they were great. But afterwards I was like, there's no fucking way I can do this. And I emailed them and was like, I would like to respectfully withdraw because I don't think I'm right for this. And they both emailed me back separately and they were like, could you maybe reconsider though?
And that's because you didn't feel ready. Like you were relatively new in career and like,
yeah,
you didn't have
it was a terrifying job wreck,
yeah,
dude. It was a terrifying job wreck. And that's the time when I realized like fully and truly, it is true. Job wrecks are all wish lists for the ideal perfect candidate. They're not actually what you have to get the job.
Was there a thing that they were like, we don't care that she's 2.5 years in career and just got her CCNA, like we're going to bring her on and we're going to send New Glenn to Mars someday?
Oh, like why they chose me?
Yeah, like what? I mean, so to your point, from your perspective, you're like, whoa, this is terrifying. I'm not ready for this. They saw something in you, apparently, that you either didn't see in yourself or it just wasn't clear to you yet. Like,
yeah, I still struggle to see it. If I'm being 100% honest, I still often feel unqualified for this position that I've been in for almost 4 years now. But, you know, I've heard him say some things like, you know, the important stuff he saw, right? Like there's no way, and I can talk about this more if you guys want, because it's an interesting perspective, but like you can't really be fully qualified for this job. Like it's like he didn't have the experience that the ideal perfect candidate would have when he came on board. And he's the one who designed the network on the rock.
Qualified for any of these jobs, right?
Good point. That's a very good point, right?
Because there's so many parallels to your story. I didn't feel smart enough. I failed out of computer science. I didn't think I belonged. I didn't think I could get in. All the things you've said over the years, which I think is just why I've always been such a big fan of yours. I'm like, yes, yes, yes. Like it's entirely my story. And then years later to find ourselves in these roles, they're terrifying to even think about, let alone say yes to, let alone, you know, try enough to open ourselves up to failure and like all that stuff. It's just, but there is, and again, we've spent years on this show, I think, trying to distill, you know, the first 100 episodes, we're interviewing 100 people on like, how do you do it? What's the secret sauce, right? And I don't know if we've ever gotten to it, but there seems to be a core, like, I think being a learner, right? I think like you showed.
That's it, I think. Yeah.
Yeah, you have to be like open to new ideas, being willing to learn, being willing to fail. And I think you learning publicly was brilliant in hindsight because what else is better, right, William? Like if you're going to hire
a hot
someone,
take there. I think, if I don't know anything about the NFL draft or these draft processes except the NHL draft. I like hockey, but it's almost like a draft. Like you're drafting for a team, the right team. You know, if you see someone out there that's thirsty, they're hungry, you can actually see their thought process and the way they're learning and they're throwing stuff out there. And hey, if they don't know it, they're reaching out, they're trying to figure it out. You can see that hunger, you can see that thirst. I'd take that any day of the week over someone that knows everything, that already has it all figured out.
That's the consistent thing that I've heard from more experienced folks, and also that I've come to realize myself when I start looking for people that I would, you know, because we're higher into networking positions every once in a while, right? And like that's what I look for too. So it's I think the term that I like to use the most to describe that is intellectual curiosity. You don't stop wanting to know why. In my previous career that I hated, I got in trouble. I got like written up basically, or whatever the adult version of that is. I don't know, for like asking why. Sorry, I have so much disdain still for that career.
There's a demerit.
There's trauma in there. You can hear it in my voice. But yeah, I always wanted to know why. I wanted to understand. And I'm not a savant. I'm not a genius. I don't think I'm really that smart, but I just keep digging into that rabbit hole, like going down and like learning things. And that is really the key. Like if you want that, if you have that passion, then this is a good place for you to be. And that's what people look for, right? Because you can be taught things like technical stuff you can learn, right? As long as you have that attitude, that learning attitude. So.
I always thought everybody was good at the same things. I thought that my struggles in career, let's say, was because I didn't have the thing that all the people had, right? Mm-hmm. As it turns out, our friend Mike turned me on to Now Discover Your Strengths, which is his book. And I realized like, oh, people are good at different things. But the good news is, you have, I mean, honestly, it's like the fingerprint, like, oh, we're all special, right? But like, we all have these unique combination of talents that are valuable in the business world in getting a job. I have been plagued by curiosity my whole life. And I say plagued because like it never ends, right? I go down every rabbit hole and it's not super efficient. Like if I have to learn the thing and then I get interested in all this other cool stuff. Yeah. Well, man, I've learned a lot of other things. And then they're like, did you learn the thing yet? I'm like, dude, but let me tell you about these other 14 things that are related.
So relatable, Andy.
Right. I know.
Relatable.
But curiosity is magical. I think in this, like how we're talking here, like if you're going to hire, like my wife had a thing, she played at a high level in basketball and she always had this saying, which I love, you can't teach hustle. There's players who are going to dive on the ball, jump on the ground, wrestle for it. And then there's players who are never going to do that. And you can never teach an athlete to hustle, right? Mm-hmm. And curiosity, I mean, I don't want to say you can't teach curiosity, but the curious people I know, like myself and you two, it's just a fire. You can't stop.
Yes.
Like,
right? I don't know that you can teach curiosity.
I don't know if you can. I don't want to say you can't, but it doesn't appear to me you can so my wife, love her to death, married her, best wife, mother in the world. She is not curious about almost anything. Like it's just not one of her strengths. She's amazing at what she's good at. So again, I think that I'm amazed at your story and I'm amazed that curiosity and being willing to learn in public seem to be some secrets. Those secrets we're trying to share with the world, with the community, right? Like, what can I do to do the thing or learn the thing? Or like, man, we've always said create content, get out there, be vulnerable, do something. You're streaming yourself learning, yelling at a book. Like, if you look at that on...
I can't believe people watch that.
I loved it. But if you looked at it on paper, you're like, that's...
Yeah. Because
I've had super nerds like, go learn math and calculus. Like, you don't need to create content. Okay, well, that's your path. But like, that's not my strength. I'm a communicator. And so... Anyway, I know we're kind of, I lost.
Well, talk about it paying off too, like seeing that rocket launch. Like if you think about like, okay, like I remember this one data center project I did, refresh some hardware, configure, by the time it was done, I'm just like, I'm out of here. I don't want to see a router, So, building or just doing anything that contributed to that thing going into space. I can't imagine the feeling. I
can't describe it. It was, and I'll tell you what, I can't go into details, obviously, but like the 1 to 2 weeks leading up to that launch were like most insane I've felt in my entire life. Like in any career I've had, like
it starts to close in, right? Like we're getting.
It wasn't even. I can't even. I wish I could get into it, but it's just like technical stuff comes up, and it's a week before launch. So it's that launch was, I mean, the culmination of my career so far, I would say. It was, and we did it. I'm sorry, if I could just brag, we did it perfectly. It was perfect, So obviously there's stuff we want to improve, which I can't get into also, but like it, so very, very, very proud. So
we made it 20 minutes before you said, I can't talk about it. No, it's good, right? No, but don't be sorry.
It's a new record for me.
Well, like if we mess something up, maybe like some financial, like something happens that's like, oh, this broke and someone couldn't use an application. You mess something up in aerospace and like, oh, that's a problem. It's huge impact. You don't want to go there.
So this is a good segue. I have some questions that I thought long and hard about on what Lexi might be able to talk about. And obviously you're going to tell us if you can't. So I think that's a good segue, William, because I thought of like, I don't know, design principles, right? Like what would be some design decisions you might make in a general term that like is on a vehicle that you cannot dispatch to, console into. There's some autonomous. So in my new role, we talk about these event-driven networks and these autonomous self-healing kind of things and using some logic to have the logic do the thing instead of
self-healing.
Right. So I assume in a rocket, right? Again, I know we can't talk specifics, but once you light the candle,
it's autonomous. Oh yeah.
So,
a lot of people, I can say that. I mean, like I could tell you a little bit about
it has
just
to
in
be,
general.
right? Like
it does. It does.
There's design considerations, I guess, made. Like, yes, there's redundancy, but there's limited space. Yes, you can build resiliency, but weight is a thing. Like, so you're under these constraints. Nobody says you can't put that many switches in the data center rack. It's too heavy. But in a rocket, right? So, I don't know.
You're thinking about it exactly the right way. And we can tell, I can't tell you how we solve these problems specifically, but those are absolutely, like, you're on the exact right track, right? Like, that's
such unique problems to space. You've talked about it, like, with radiation and vibration. And, like, I mean, I went down a rabbit hole today and thank God I got busy with something else at work and couldn't. But I thought, okay, so, like, I went nuts about, like, all right, so you got packets flowing through, I don't know if it's fiber or copper. She'll never tell us it's fine, but, like, all right. So, like, I'm thinking about what Einstein said and warping time and space with, like, speed and distance and in your space. I'm like, no, I went nuts, right? So then I'm thinking, like, well, I wonder if, like, the speed of the vehicle, they might be going 14,000 miles an hour. Like, does that change how electrical impulses or light travel? Like, I just can't imagine. And again, I know you can't talk about it, but just the crazy cool stuff that you must have to work on and test and check. Radiation is an example, right? Like, I don't know how the hell to shield a thing from gamma rays from the sun. And was there a solar burst last week? And and like it's all just so amazing to me. Like, what
you're
you guys
thinking about it. I mean, Andy, you're thinking about it like an architect, like a designer, right? That's how you think you have to think about it, though, right? Like, you have to sort of like you're putting yourself in the architect.
But that was new to you, right? You went from a knock to like, oh,
yeah. I let me be clear. I did not design anything, right? In this network, I am an integrator, which means I take the hardware and the firmware and the software and whatever, and I smush them all together, and I give all these individual, like, contributors feedback on how their stuff did. And then if there needs to be tweaks, I test the tweaks and so on, right? But that's
interesting. I thought you were like, I always considered you like, oh, like you're the network engineer on the rocket, but an integrator, I guess, is a different thing,
technically, right? I mean, I am a network engineer by trade, but my job title is network integration engineer, which means that I smush everything together and I see how it works. And then all these individual contributors, like I said, we've got embedded software folks, we've got a firmware team, we've got hardware folks. Like, I give them all feedback on how the device performed and what the network looked like. And even though I'm not an embedded software engineer or like definitely not an EE, right? Like, I still can give them useful feedback because I know exactly how the network is expected to perform. And so together we work as a team to figure out how to make it.
And everything traverses the network on the rocket, I'm assuming, right?
It does. Yeah.
Like we just had somebody, like, we did cruise ship networking with a guy.
So cool.
Well, it was kind of neat, right? And he was talking about, there are mission critical systems that are on their own networks and segmented, like, and I get that, and that makes sense. I'm thinking like, well, whoa, like, are the rockets, like, are the things that move the nozzles so that they can change the trajectory, like, does that go over the network? Is it something else? And again, I know you can't answer it, but like, these are the cool, like, to have that type of job. I would love to work there just to be able to, like, have these like the curiosity, go down all these rabbit holes, like, holy crap, like, what is on the network? What isn't? What does that mean? Like, oh, I got to talk to the rocket guy because, his thing has to steer and the nozzle thing. And well, that latency isn't bad. And what about, like, it's just so fascinating to me. I could just imagine you're all sitting around, well, yeah, on like a whiteboard, like, all right, here's what we got to do. And here's all the constraints. Like, how do we do this? And then they're all just looking at Lexi like,
well, okay. I'm lucky enough that I actually made a little post about this the other day on socials. And then I was like, I should not make this permanent because people from my job are going to be like, Lexi. But being a designer. So my mentor is the architect of the network. So I didn't design it. He did though. And so, that's why we did a little talk at Cisco Live this year. And that's why I was like, really the talk, I was there, but like, I was trying to get him on stage to talk.
Oh, is that the tall guy I met at Cisco?
Yeah. Eric. Yeah. Okay. Yeah, cool. He rocks. And I've been trying to get him on stage to talk about this stuff, and he finally did this year. Just a quick little plug. It went great. It's on demand on the Cisco Learning Network. Okay. But anyway, we did a talk, and
we'll put a link in there. I haven't seen that. I'd love to see that. You guys talked about some rocket stuff?
Oh, yeah. We definitely, it's called Packets in Space Networking for the Final Frontier.
Man, I'm sorry I missed that. I will definitely.
That's a title right there. I like that.
What was it? Packets in space?
Packets in space, networking for the final frontier.
Y'all are talking like way cooler stuff. Like I read this book called The Martian like years ago. And you know what I thought about like the whole time as I was like reading this book is like, man, I could transfer like a JPEG from like Ashburn to Chicago in this amount of time. Well, Mars is like 150 million miles away. I don't know what the exact distance is, something like that.
Yeah.
And how long would it take to transfer that JPEG to Mars?
28 days.
It
Crazy.
depends on the network you have connecting you to Mars.
Yeah.
What's your network doing?
Well, that's one question I have is like we're talking about like the network on the spacecraft, but do you like what about everything surrounding the spacecraft?
Yeah, so that's a great like actually we should clarify because some people when I talk to them get a little confused understandably about what network I actually work on. So there's the rocket network and that is my domain and it is a closed loop network, which means like for the most part that data is only flowing like within the rocket and that's it.
But
right?
Telemetry.
Yeah, but we do get telemetry on ground, so there are radios and stuff that like send it to ground in certain ways, right? But for the most part, like it's an autonomous vehicle, it's a closed loop network, all of that is talking. That is my domain. My domain is not the ground network, which we have a whole network engineering team that manages that just in Florida, right? For just the ground network, which in some places does interface with the vehicle network. So, you know, I have to work with them. And then we've also got like TDRS, which is like the NASA sending data down to ground and how we manage that. And then we've got vehicle recovery when we recover the first stage when it comes back down onto the sea, onto the boat, basically. Like, how are we going to recover data right there? Like, there's a lot of different networky things that have to be addressed.
Wow.
And they're all addressed differently, right? And my domain is solely the rocket. So there's a lot of interesting people to talk to actually out there who know way more than I do about all that other stuff.
Yeah, I watched something on NASA. NASA has like this deep space network thing. And I watched a YouTube video. Like it was fascinating. I need to go back and watch it. A lot maybe changed and yeah.
Yeah, well, NASA has published, you know, NASA has some things that they can't publicly like put out there, but they do have a lot that they can and do. And so anybody who's just like even passing interested in any of this stuff, I do recommend you go watch some stuff or read some stuff about the Deep Space Network. And I think even the European Space Agency, ESA, they've published some stuff about like even I think what protocols they have on some of their crafts. So it's an interesting read, like anything you can get about that stuff.
I have some specific questions I want to ask you, and to preempt you may not be able to talk about it. I've heard you say in other places publicly that you're, I can't talk about it because of different, I don't know if the regulation bodies or whatever, but like I've heard you say ITAR, and
yeah.
I don't know what that means. And again, I'm curious, so I have to ask.
I forget what it stands for. It's like international.
Yeah, I looked it up as we were talking. So international traffic and arms regulations. But like, so yeah, of course. So when I ask you a question and you say, I can't talk about that. ITAR, I guess, is one of the regulatory bodies that you have to adhere to in your job, right?
Yeah, it's federal regulation. Yeah, so like the rocket, any rocket that if we share that information with a foreign entity, that violates ITAR, and that's basically TLDR, because if you share how to build a rocket, you're sharing how to build a bomb or a missile, right? A rocket is essentially like a controlled bomb.
So if you violate ITAR, like you're going to federal prison. Yeah, right. Like it's no. So
yeah, and
the stakes are so high. Like what William said earlier. I'm sorry, I mean to talk over you. Like oh no, the data center went down for a minute and somebody couldn't get to an application and use their Visa card. Like where you're like,
yeah.
I mean, you guys might eventually have humans going to Mars or something, or like some crazy thing, and the stakes are so high. Not only that, but also communicating, because you're a public figure and you're a good communicator. You want to be able to share this cool stuff with the world, but you also have to be super mindful because you don't want to go to federal prison. Right?
I use ITAR as it's a very convenient excuse for not creating very good content online. Like, I can't talk about the interesting stuff because ITAR. No, it is the reason why I can't share. Unfortunately, I would love to share all the nitty gritty details, but
you're gonna have to get a job with Lexi if you want to.
Yeah.
Learn any of the really cool, amazing.
My mind just blew up just thinking about like how like ITAR would differentiate between like military and commercial space stuff. Like that's got to be I bet the handbook is enormous. There's probably a lot of
and I'll say, but not only am I restricted by ITAR, but also we have some NDAs in place and stuff like that. And so there's proprietary stuff I can't share that may not violate ITAR, but would, get me fired. So I do paint with a very, very broad brush about everything. And if in doubt, I just don't share it. And so there might be details that technically I could share, but I'm just not going to risk it type of thing.
Have you been like called into the principal's office yet of like, hey, okay.
No, luckily not. No,
clear what you can and can't do.
Yeah. After three and a half plus years there, I'm pretty good at like avoiding that stuff.
I guess in the beginning you just defer to like, listen, I can't talk about anything. I'm not losing my job.
Right.
Go to jail.
Right. Or I'd like message Eric and be like, hey, can I talk about this? And he'll be like, no, or yeah, that's fine, or don't risk it, So I've learned over the years.
So my first question you might say no to, but I tried to fashion these in a way that maybe we could talk about. And we kind of touched on this earlier, but how do you design a network that can recover or adapt without human intervention during flight?
I mean, that's such a good question, Andy. I really like that because there's a lot. I mean, like that's one of the questions that you ask when you're designing.
But is that like vague enough? Like, I mean, there's probably redundancy protocol. Like, I'm going to try to answer your question for you, which is probably dumb.
Yeah.
But like,
please,
there's probably redundancy protocols. There's probably dual things. Right, like physical redundancy and then logical things to, take advantage of the physical things that we do on the ground.
I answer questions like this because it's a totally valid and interesting question to ask. I answer questions like this with not how we solve these problems, but think about how you might solve it, right? Because there's not one way to solve these problems or address them, right? And it's something that I've had to learn being in aerospace is everything is kind of just a big risk assessment. Like every decision you make ultimately comes down to what's the risk and are we willing to accept that, right? So whatever you decide on, whether it's how you address radiation, temperature, if you want to use redundancy in certain places, how much of it do you want to weigh, is weight okay versus, better resiliency of the network, or are we willing to accept the risk of like less weight, less cost, but less resiliency as well? Like all of that comes down to a bunch of smart people making a decision, or at least analyzing the options and laying them all out in front of leadership and saying, here are the benefits, here are the disadvantages, here are the costs associated. What do you want to do? Right. And so that's all it is. And it just depends on your company's strategy, your leadership's attitude towards certain things, how they get addressed. And so every company is going to be a little bit different. Like we obviously would be very different than other, space rocket making companies. I
guess the problems, I'm sorry. I guess the problems, like a network is a network, and the problems that we face are similar in a lot of ways, and the protocols that exist to like solve them, with the exception of some of the, like you had said, the vibration, the temperature changes, the radiation, which I guess there's separate mitigations around. So
maybe not.
Yeah, right. Like
just depends. Yeah, like
and what it's on the ground, like the money thing, right? Like we could have 5 nines in the industry, but generally when people are signing purchase orders to buy the gear to design the thing, like, well, what corners can we cut? We don't have $1 bajillion in the budget, right? Because nobody wants to spend on the network. It might be different in rockets, but the network is like this necessary evil. It's the roads, it's the plumbing. Like, we just want to spend our money on applications and dev. Like, the networks are stupid. Cloud made it easy. We don't need you anymore. I mean, I'm being half like, facetious.
No, you're not wrong.
So on the ground, when we'd have a big outage and Bank of America would be like, what the hell, guys? Like, why did this happen again? The answer was always somebody made a decision to not spend the money we could have on the resiliency that would have kept this up. Now, you can't say that to the client, but that was always the answer. Not always, generally, because you could build enough resiliency in the system, but it's expensive. And you're going to have to refresh that expense every 5 years or whenever this. So again, I know you can't answer it, but it's interesting that problem on the ground. There's an unlimited kind of budget, right? Like,
it's a similar like risk benefit analysis going on. The stakes are slightly, a little bit different here and there. But we've got some of the differences are interesting to me from a business perspective. I'm not a business guy, right? Like I wouldn't say I understand business decisions and leadership very well, but the things that I have learned have been basically like risk assessment. Everything does come down to weight, which also basically means it comes down to cost, right?
Yeah.
And of course, everybody's trying to save money, especially in like a private company. And I'm not speaking as a representative of my company. It's just, this is what I've learned in general about private aerospace, right? Is like, that's one of the things that you just have to deal with. And that also means that schedules are tight and things like that. So all of that is kind of pretty familiar, I would guess, for most network engineers. It just sort of manifests a little bit differently maybe, and like what's prioritized, because in a rocket everything is expensive and you're trying to make it, less expensive in every single possible way you can, but you also like can't necessarily cut corners, right? So you have to come up with these inventive ways to save money and also get it done really good, right?
Yeah. And in the network engineering world that, Andy and I probably lived in for a long time, it's like, hey, you want more nines? Hey, double the cost, triple the cost, quadruple the, okay, yeah, we're not going to do that. We're just going to go, what is the cheapest? Okay. Like, I feel like my assumption in aerospace, especially, name the company, if you have something going into space, if you cut corners and it, results in rocket going down, then what is that risk? Like, how is that calculated? It's a big, you might as well light a few truckloads of money on fire.
Yeah, and I'll say like terrestrial networks and like data centers and stuff like that, for the most part, like your just typical one, you're probably not going to have a bunch of people before it ever gets deployed to be like running a ton of tests, a ton of like, working with the FAA to make sure it's going to perform in production exactly as you expect it, things like that. Like when we get the rocket on the pad, like I'll say like when I was stressed out in the weeks leading up to launch. I was not stressed out when we were trying to when it was on the pad. I was confident in the network at that point.
There's a ton of testing, I assume.
Oh, yeah. And we have, in aerospace, you have requirements. You can't just sort of like build a thing and see if it works, right? Like you have requirements that systems engineers are very important in an industry like this, because they have to understand how their individual system fits within the whole and take the requirements of the large, you have requirements for like the rocket basically. And then its requirements trickle down into more specific ones for each little system, the fins, the engines, whatever, the flight computers, and the network has its own set of requirements. And so you write those requirements, and the systems engineer, make sure that in the end, your little system performs exactly to those requirements. And if it doesn't launch, right? So
yeah.
There's an amount of like, maybe like, okay, like we test things to make sure they work. Maybe we have like burn-in, we install a fresh switch or a router, we let it burn in, and then we get it going. I imagine like in space related things, aerospace, like you probably stress test stuff a lot more than you would do.
You definitely have to know the limits of like, we know, generally things like vibration levels, temperature, like we have a whole radiation team that knows what to expect for different missions that we're going to do. Right. And so we definitely choose our components wisely. And they're analyzed before we ever commit to actually using them for these purposes, right? So, and then each unit gets tested before it actually is put on the vehicle to make sure it's not defective.
I'm glad you said that. I thought about that today. I visited Oak Ridge National Laboratory. I forget if it was a year or two ago. And we were there to see the Frontier supercomputer, which is really neat. But a part that we couldn't film or talk about was a nuclear reactor where they made isotopes. Ooh. And part of what they did there, it was fascinating. Part of what they did there is they test physical materials, and they mentioned rockets. So they can shoot neutron bullets from the radioactive whatever through materials. So a company can say, hey, I don't know, here's my spacefaring whatever. I don't know what I'm talking about, right? And tell us how strong this is. And somehow they send the neutron bullets through the material in this cool thing. And then they send whatever the results of that test are over to the supercomputer and do some math. And like, okay, you can get 37 launches out of this at these temperatures, at these things. And they can like tell you with mathematical, like scientific certainty, I think, based on what you built and what we tested with neutrons. I'm like, what? Like just, so physical material testing, I didn't even know it was a thing.
That's the coolest thing by far that I think I've done so far, besides the rocket launch, actually, is like, I was lucky enough to be basically the test engineer for some components that we were testing radiation this year. And I went on a couple trips with our rad team, and I got to see that firsthand and like watch them. They definitely do have a profile for each mission. They know exactly what that's, based on the radiation testing, what's going to happen with that component. And it is super cool. Way beyond me. Yeah,
They must
the
have
rat
some
team.
really cool laptop stickers. Like, just the name of their team.
They are awesome. They are so smart. I learned so much when I was traveling with them. So that's definitely like something that happens for sure.
Did you all know that man, I don't mean to derail this in any way, but speaking of space, I was having breakfast with someone like the first day at Cisco Live and like, William, they're launching data centers in space now. And I just started like laughing at him like, yeah. And he's like, no, I'm serious. There's a startup and they're shooting data centers in space. I'm like, are you serious?
Yep.
I think it's called like Cloud Castle or Space Castle or something. It's legit though.
Yeah.
And I was like, why would you, like my mind started reeling and I'm like, why would, I don't understand. How do you get
Have
the
you
data?
seen Maxie Reynolds subsea, whatever it's called?
Like, what
She's
about
putting
data
them on the
gravity?
ocean-
That's like,
she's putting them on the ocean floor. They're putting them in the ocean.
Oh yeah, that's pretty
I've
cool.
seen that.
Floor stuff.
Yeah.
Yeah.
But he was like, yeah, of course there's no, temperature problems in space. I'm like, oh, that's a good point.
Well, there's
Yeah.
definitely temperature problems in space. I don't know that that's true,
Like
right?
cooling aspect of it, I guess.
Well, it's cold, but it's also as soon as the sun hits you, there's no cooling with air. You get super hot and super cold in space. It's a big challenge.
It
But
is.
yeah,
that's
that's
like
neat.
they're doing crazy stuff in space with technology and data centers. I have
Let's see what the name of this company is because I'm curious now. I can't remember now.
Is it Star Cloud?
Yes, that's it. Not space. What did I say? Space
I
Cloud.
was trying to remember the name because I've definitely heard of them, but yeah, Star Cloud.
That's really interesting. I need to do some digging.
the place I work at.
Thanks, Ankit, for telling me about that.
Ankit. I want to talk about telemetry for a second because I know that's really important to space vehicles. And the place I work at, they're obsessed with streaming telemetry, and they think that everybody should be using GNMIC, and you should know everything about your network all the time. And I just heard a Packet Pushers actually where they had. So it's not a product pitch, but yes, everything is streaming telemetry where I work, and that's one of their value props. But I just heard a Packet Pushers where they kind of had like an SNMP versus streaming telemetry face off of like the SNMP people are like, do we really need to know what the network's doing all the time because SNMP is good enough? So it was an interesting conversation, but I guess in the context of rockets, I think you need real-time streaming telemetry coming in over what I assume is a limited WAN connection. Limited might be underselling how much bandwidth they can do over satellites and all that. It's probably pretty intense, but so I think of quality of service, right? Like, can they stream everything? Do they have to prioritize certain things? And again, I feel like I'm dipping into like, bro, I can't tell you what we're doing, but these are some of the things I think.
But you're thinking about it right, as usual. Yeah, you've got it right.
I mean, you need the telemetry to know what the rocket's doing, I think.
Mm-hmm.
But
I can't say what I can't say is like
autonomous. Like, do you need it on the ground because the rocket's going to use
think
that
about
data
it, right?
in the closed loop and like make adjustments?
It's autonomous when it's going up. We get a little data coming down to ground as that's happening, but for the most part, very limited. But like one of the most interesting things that was so different for me coming from like a knock where you have this huge like screen of like, this is wrong, we're freaking out because everything is wrong, right? You never get an alert if something's right. Right? Like you don't care if it's going right. You just
Is that what telemetry's for? You can see everything's happy?
I mean, yeah, in aerospace, we do want to know the exact everything that's going on with everything all the time, every millisecond, right? Like we want to know if it's going right, if it's going wrong. We need to know immediately if something's wrong.
That feedback loop can, I guess, help you continue to keep everybody safe and the mission.
Yeah, I mean, it's part
successful.
of,
but also future too, right? Like I think of catastrophes we've had in aerospace, and the streaming telemetry started to send information before crafts fell apart. Let's say, like, leading wing temperature sensors are starting to go crazy. So.
Is there like micro adjustments you can make? Like say that like you have all this data coming in, it's all real time, and there's like a combination of certain things that give you insight into like, okay, this could potentially happen. Like, could you, in theory, make adjustments if you
like Apollo 13? Think about that, William. The telemetry was telling them the oxygen was disappearing, and they were like, "Shit, we need to shut stuff down and go into another thing and put socks and carbon things to like scrub." Like if they didn't have that information coming down from the craft, and all the smartest people in that room could like work a problem. Like that's what I think is like,
I feel like I've oversimplified that like an idiot because you have this autonomous, gigantic thing in space. It's like, what are you going to do to,
Yeah, I mean,
that's why you have all the good engineering and the Lexis of the world that have made sure that everything's like,
I just test stuff. But you've got kind of a difference between like piloted vehicles with human beings in them and like an autonomous vehicle, right? Because right now there's no people in the rocket. But you know, maybe one day we don't know. But yeah, you generally want even if everything goes well, you still want as much data as possible because you want to know exactly what was going on and you want to be able to analyze that. And of course, if something goes wrong, you want to know, but it's also useful to have the data about what was going right, you know, and be able to confirm things, or if you want to tweak something later, you know, it's constant learning process with this stuff.
Well, you're testing stuff and you're getting data when you test it. And then when you quote unquote test in production, when you light the candle, then you can get that data back. Like, okay, great. Everything we tested happened. We confirmed it. So let's keep doing the good thing. So that kind of makes sense too, I guess.
Yeah. Mm-hmm. And you might have heard of the term deterministic networking, right? With safety critical stuff, determinism is really, really important.
Can you explain deterministic real quick?
Yeah, it's basically like, I don't know, I think there are ways we can do this in data center and enterprise networking for sure, but I wouldn't say like deterministic networking is kind of like, you know exactly what your latency is at all times. You know exactly the path that traffic is going to take at all times. Like it is deterministic, right? So like in data center networking, we can adjust like dynamic routing rules and things like that to make sure we can tweak things or statically set a few things here and there to make sure it takes
traffic
a certain
engineering
path.
Almost, you know, where stuff's supposed to be.
Yeah, but it's like the extreme level of that basically, right? Because it's safety critical stuff, which means like you really, really have to be on top of it. You have to know exactly what's going to happen with that data at all times and nothing unexpected should happen, or at least the chances of anything unexpected happening are so mathematically low that you are confident enough to launch this thing, right? So
it's like you're producing consistent, predictable results, I guess, with the same inputs every time, no randomness thrown in that can add variability.
Yeah, and there's like, you know, algorithms that people can use to like determine like how many times out of a million will this fail, right? Like there are, for every individual component basically that exists. I forget what the term is, but it's like a scale or something that exists out there. And you can take that for every component on a vehicle theoretically and mathematically calculate how many times out of a million is this rocket going to have a problem or something like that. So that's another thing we use to de-risk.
Like mean time to failure or something, right? I kind of
something
feel
like
I've
that.
heard that in like network.
It's like a standard.
Or...
It's a standard. There's a handbook. I'm pretty sure NASA uses it. I'm sure you could Google it if you knew what to Google. I can't remember.
So I know we've been going for a while. I want to be respectful of your time. There's two things I have to touch on before we wrap. But something just occurred to me because I was listening to, I know I keep mentioning it, but I listened to you on another show and you were talking about the Ethernet book that you read all 6,000 pages of 4 times. And you're like, nobody should read it. It was really hilarious. But something you said was just jumped into my mind was you discovered time-based Ethernet or time-triggered Ethernet. Or like that, right? Like
that's one of those.
Is
many
that
protocols.
A thing in space? Like,
I mean, it
so
was developed for safety
that?
critical applications. It's so interesting. It's like QoS, but at layer 2, kind of, is how I would describe it. Time triggered Ethernet is a proprietary protocol by, I think they're called TTE is the company. But it's just like if you start looking into like aerospace stuff or deterministic stuff, you can kind of find protocols like this out there. Like NASA will talk about them. I think TTE, the way I kind of found out about it was like ESA, the European Space Agency. I'm pretty sure they posted something about it, or TTE was like, oh, we have it on one of our vehicles or something. But yeah, it's, I would just describe it very briefly as like QoS for layer 2. It's very, very interesting. It's like Ethernet, but more than best effort, right? Or typical Ethernet is best effort, right? It does its best, but it's not going to guarantee. This would give you some kind of
guarantee class of traffic at layer 2, maybe. Yeah. Okay. That's kind of interesting because time is critical, right? Like milliseconds matter.
Yeah, so like it's not, it could also be good for like not just aerospace, but maybe like industrial applications or even automotive or something like that, right? So it's just down to your use case. So if you start like looking into this kind of stuff, you'll find protocols like that. It's pretty cool.
Yeah, and there's probably so many cool protocols in aerospace that are unique to.
Yeah, and a lot of them are proprietary, unfortunately, or they're so new that the IEEE just came out with them or something like that. And there's no like, what's crazy to me and what makes me sad as someone who has ADHD and needs structure to learn is that there's no certifications to like learn about these things. No one has a course on TTE that I am aware of. You have to go, time triggered Ethernet. You have to go to the company that made it and like talk to them and like pay them money to like talk about it, right?
I'm
So
with you. Same affliction. Give me an accredited course and a book and a course I
give me
can
an
take.
instructor
I
to
need
just tell me
structure.
things. Yeah, give me quizzes and tests. I want that, right?
Please
Like,
give me structure. Don't just give me a
that's-
book and say good luck.
Right. That's the most frustrating part about like rabbit holing into some of this stuff is like it's so brand new or just like unexplored. There's no certification paths. Like you just have to kind of go into the unknown.
So we talked about deterministic stuff. Is like that time-based Ethernet, is that the whole genesis behind, this deterministic space communication, I guess?
No, I think determinism has been around for like a very long time. I'm sure NASA invented this, right? Like NASA invented systems engineering. So I don't know for sure where determinism came from, but I would suspect it's definitely because of safety critical requirements.
But
right?
is that what makes the space communication deterministic, though? That protocol, is it like part of the process for how you? Because I mean, I drive for determinism in my code. Like I write code, I have the same inputs and I want the same outputs. Unfortunately, that doesn't happen, and I think it's how much more complicated freaking space is. And
yeah. I mean, I would imagine, like I said, TTE is like one protocol out of many that exist that are either like invented with this kind of use case in mind. And I just say like this is a possibility. This is a potential thing that you could use depending on your use case to kind of make your network more deterministic. Oh my God, my dog. I'm sorry.
That was amazing.
I thought that was Andy.
Is she okay?
She is fine. I don't know.
I heard. It sounded like a Muppet. Roar.
She does this thing where when she wants attention, she rolls around on her back and goes.
All right. Remind me her name.
Sorry. Her name is May.
May.
When that
I
happens,
apologize.
Andy
I'm
was
wrapping
like
it up.
this.
That's gonna should I redo that because that's
it was amazing. It was great. I love that. I love that May was like, "Yo, enough. Tell this guy to shut up. It's been 55 minutes."
Tell me.
All right, May. I'm gonna wrap it up for May. Okay. So second to last thing, security. There are obviously massive security concerns.
Yeah.
Everybody's worried about security and networking. Okay, you hack my network and you give me Bitcoin to unlock your stuff, whatever, right? Where I guess if you hack a rocket, you can actually weaponize a controlled explosion bomb, right? So like, what question am I trying to get out here? I have it written down. Let me look.
Is security important? Yes, it is.
Right.
Can I hack the rocket? No, you can't.
What are the so are there unique security considerations beyond the obvious, like, oh yes, you could do terrible things on my rocket? Like, so comparing this to ground networking and security, you have to think about your attack vector, your surface, whatever they call it. And you might have firewalls and like, you got to think like cyber stuff. And like, I mean, without telling us anything, you can't tell us, like, do you have to do special things around security for a rocket? Or is it really just, hey man, this is networking and you secure your network? Like, it's a terribly worded question. I'm sorry, I can't ask this better,
I understand. No, it's fine. I will say
regulated, it's classified. It's like it's, I feel it'd be different things that you'd have to do.
Honestly, regardless of how you had worded it, I will just say the answer is you definitely have to do some stuff. And that was all I can say.
Yeah. Right.
Yeah, I'm so sorry. That's
even access to systems. I used to have low-level federal clearances, and there's the PIV-I card, and there's a fingerprint scanner, and there's a special laptop, and there's 13 VPNs. Like, there's layers of security that, just to get access to a system. So I guess we can just assume security is.
We definitely, it was designed with security in mind. Yeah, for sure. Yeah, for sure.
Yeah,
so cybersecurity is a thing that aerospace companies, for anybody looking for a job, that's another thing you can look into, right? Mm-hmm.
So that's a good segue, and that's kind of where I wanted to wrap us up as advice for aspiring rocket networkers or avionics integrators. What advice would you give to a network admin, a network engineer? I mean, think of you at a knock, or I'm thinking of myself at a knock, right? Like I teared up and it took all I had not to quiver into a falling ball of mush when I watched New Glenn launch at the beginning of this episode. So like, all I ever wanted to be is an astronaut. So like that, like that's a dream. So anybody out there who has a space dream but also works in tech, do you have any advice, any learning resources? Like, what would you tell somebody that's like, hey man, I love what you do. How can I do the thing? Like, this is amazing.
Yeah.
Because you're the person. I think you're the only one. that we can talk to.
I think my mentor would be a better person to talk to, but as a quick, but no. I understand.
I would love to talk to your mentor.
Yeah, I mean,
what would you say? Like, you have any
so,
advice?
Yeah, my advice would be there. So there's not really, unfortunately, there's not like, kind of like I mentioned before, sort of with like some of these protocols and stuff. There's not really like a certification path that's like, here's how you get into aerospace as a network engineer. But honestly, people get annoyed with me all the time for saying this, but like, get a CCNA, like understand network fundamentals. That's so important to literally everything ever being a network engineer. Thank you, Captain Obvious. But like, make sure you know the fundamentals. And then if you really want it, just go for it. We have job recs like anyone else, right? Just apply. Because if you look at the job recs on any website, right, I'm trying to avoid naming specific companies, but aerospace companies that might be hiring for spacefaring vehicles, there's a number of them out there. Like, just look at their job recs for, it may not say network engineer, it might say integration engineer or I don't know, avionics engineer perhaps, but look at the job rec and look what it says, and you'll be able to tell whether or not it's like network related. But my advice is like, learn your fundamentals, then go for it. Then if you're not getting it, start, if you don't, a lot of it's luck, unfortunately. Like, I got really lucky to be hired the way I did, but I would say keep applying. There's not going to be a ton of these jobs because like, we just don't have usually like an army of network engineers on a rocket, right? I'm on a 2-person team right now, but they do exist out there. Just go for it. Because you're not going to be able to get a certification to be qualified. You're not really going to feel like you're qualified for it, but just go for it anyway, because you can do it. If you understand networking, you can be a network engineer for a rocket. It might be weird. It might be a weird rocket network, but like, if you can get over that, then you're fine, right? But as far as like actual skills, if you want to increase your chances of like doing well in an interview, we talked about at the beginning, intellectual curiosity. People roll their eyes at, because we say soft skills all the time in technical spaces, but like, you can learn technical stuff. You will have to learn the technical stuff on the job at an aerospace company. There's just no getting around that. You're never going to know most of the stuff you need. So if you can demonstrate that you have the ability to not only have passion for that mission, whatever that company is doing, and show them that in the interview, and also like show that you are interested in this stuff and you think it's cool and you are really ready and willing to learn, that goes a very, 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 very long way.
She's amazing. She's had it. Crazy. I understand.
Yeah,
I kept you too long. I'm sorry. Listen, I think that's fantastic advice, and I'm glad. I don't think that it's obvious in the beginning. I've heard people try to undermine and undersell the value of the CCNA, and today's market, and like it's the best program out there for networking fundamentals.
Yeah.
It changed my life. It changed your life. It's changed everyone's life I've talked to. Dwan Lightfoot, who's now Mr. AI. Like, you talk to anybody who's just starting out or at the top of the mountain, CCNA is where you start in networking. And I believe that. I know that you're a big proponent of labbing. I love your lab content. I guess you might tip your hat to like, hey, while you're doing your CCNA, do some type of labbing, even if it's track and pacer. Tracer.
That's a good point. I will say, like, one of the things that helped me a little bit going into this particular role, which is network integration, where I had to do a lot of hands-on hardware stuff and be there in person with it. Having actual physical hardware experience and like messing with switches and routers and stuff did help me a little bit. It wasn't what helped me get the job necessarily, but it did help me like not have so much, like I was able to build a rack of equipment because I'd sort of done a little bit of that before. Whereas like if I hadn't done that, then I would have been like kind of freaked out and like treading water, or like trying to keep my head above water when I was doing it. Having built a little bit in my own lab at home helped me not be so like freaked out by that requirement in my own job. So that's just a note there. You don't have to have the physical hardware experience. I know that's not realistic for a lot of people, and that's okay. But if you really want to get an edge, that could be something to consider more than you might normally for like any enterprise or data center role.
William?
I totally agree with that so much. Like getting your hands on hardware, it sounds trivial. It really does. But I've had, like, when I have hired, like, talking about like drafting younger, like inexperienced folks, or like our college intern program at one of the companies I was at, they would come in and they did virtual learning and stuff. And then we would go in the data center and we'd go through like racking and stacking MST cassettes, fibers, terminating some copper, like how to properly patch and, all clean everything up. It would you'd see like all these light bulbs going on everywhere. It would like connect all these things that were not connected before. I can't explain it.
There's something about from your brain to your hands to the thing. It does light some things up. And that actually reminds me one more thing. I'm sorry I keep adding on, but in aerospace, you're always going to hit like a lower, like we're all familiar with the OSI model, right? Physical layer is more than just cables, right? Like if you can do a packet walk like pretty well now, I would challenge you before you go into aerospace, do a frame walk and like start with the phi and then go through the phi and then go to the MDI, like go all the way through it. And if you don't know how to do that, that could give you a bit of a leg up.
I don't know how to do that.
Aerospace.
So yes,
most you don't have to, right? Like most people don't because you don't need to.
Straight up.
Well, and that's fine, right? Because again, most network engineers, quite honestly, like don't need to know that. But if you're looking at aerospace, that is something you may want to look into. Is like
you might be programming
basically electrical. You'll at least have to be so close to it that you're not programming it, but you're almost doing it, right? Like learn what a phi register is. What does that mean? And like what does an ASIC actually do, right? Can you ask questions of somebody at Cisco about whatever this new ASIC they have is? If you don't know the difference between a phi and an ASIC, or what is SGMII? What is that? What does MII stand for? Like learn all of that, right? If you really want an edge, like that's all stuff
I'm laughing because you and I used to talk and you would ask me questions and I'm like, holy crap. Like, because they're things I had never thought of. And I asked some of the most brilliant people I knew and they were like, whoa.
Because you don't have to.
Somebody. But you're right. Like, but it's fascinating. And if you're curious and if aerospace values these, what seem to be off the, the beaten path skills, like.
Yeah, you have to be able to break something. Like if you're going to find, because most of the time on networks like this, they're going to be like the only network in the entire world like that, right? Like I can say confidently, there's no other network like the one I work on. Absolutely not. Right. So if you are going to be ready for that, you need to be able to like break down a protocol to its very base. Like what's the timing like on this very specific, how you go into like, I don't know, the 802.3 standard. If you haven't done that, start learning how to do it and then look at the like timing diagrams in there. How many nanoseconds does it take for this one particular signal to be sent out?
You got to buy that Ethernet book with the octopus on the
Yeah, it is a good book. It is. Yeah, that's exactly it. Yeah. Like just learn the low level stuff that you never would have thought to learn. And you're going to have an edge in interviews, right?
It never ends. You told me about link pulses and auto negotiation.
Yeah, the one thing I can do with an oscilloscope.
But whoa, like really? I thought I knew a lot. Like you never know it all, and somebody always knows more. And you discovered that some vendors say when you turn auto negotiation off that it's off, and Lexi is like bullshit. Just because you turn it off, I still see your fast link pulses. Your auto negotiation never turned off. Like I don't even know if they know that, honestly. Like
because I have asked several vendors about that, and they were like, what? And then they ghosted me.
Like the hardware engineers who like design that platform that are responsible for refreshing it every couple of years. Lexi walks in and she's like, yo, I turn auto neg off and it doesn't turn off. They're like, that is not true. Want me to show you?
I have.
Well, think about it as like a normal network engineer like think about ASICs. Like we're going to look at like the spec sheet and that's it. We don't go beyond the spec sheet usually. We don't have to.
But how much time does it take for that ASIC to make a decision? And can you rely on that every time? Right? Like that's the kind of level of questioning that you need to have. And like, again, I'm not saying that you should know this already. If you're expecting to get an error, you won't know it. Like there's no way you will know it. But if you can just get used to thinking like that and sort of explore a little bit of this here and there, look at some white papers or a standard or whatever, that'll get you into the mindset of like, okay, well, what actually happens when a frame arrives from the wire right at the phi? What does the phi do with it? And are there sublayers in there? And what do those sublayers do? And is it different for this flavor of this protocol versus this flavor? Like just start out.
I said on something magical, the mindset. I was just thinking of Erica the Deb, and she's I'm going through her automation, YouTube that she's doing, and she starts out with the mindset Like, listen, this like coding is a complete different mindset. Dev is a different mindset, which is why it's really hard for a lot of network engineers because it's a completely different mindset. And I think that that's brilliant what you're saying, that if you're interested in aerospace and you're studying for CCNA and all that stuff, you if you can start to get that mindset, well, like what are these things? And like, because I've never had that. And the more I talk to you, I'm like, whoa, like it is a whole world unto itself, and you can dive in, and that'll really help you in an interview if you can at least talk about some of the things that you just touched on.
Yeah.
You're talking about going deep in one area too, though, because like most network engineers nowadays are, I don't want to say, I hate saying most, but a lot of folks are just generalist in a sense. Like they're generalists because they have to be they're kind of deep in a lot of different areas, but you like the work that you do, you're very deep in a very specific area.
Yeah.
And there's something really awesome about that.
Well, and there's no shade to generalists. Like you have to do what you have to do.
It's the opposite of what they're asking for us, right? Like you got to know cloud, you got to know networking, you got to know cloud, you got to know some programming, you better know pipelines. Like now you got to know AI. Like it does seem like it's going more generalist, but here's Lexi who's going deep on really cool stuff. And I don't think you're going to be a generalist and succeed in aerospace networking, at least.
You need to go deep. Yeah, you can go in as a generalist. That's fine, right? So don't be afraid if you feel like you're a generalist now. If you don't want to, it's fine. But you just have to go in knowing that that's what's going to happen. Is you need to become an expert on your network and no other network. And you kind of need to, like I know I said, get the fundamentals, and you do need those. But then you have to be able to set those aside and go, all right, so what's this weird thing doing right in front of me? And be able to like work with those in tandem, if that makes sense. And you have to be able to explain some of those concepts to other engineers who are not network engineers, but like electrical engineers, mechanical engineers, software engineers who will think they know networking, but don't necessarily.
Shots fired.
Never.
All right, Lexi, in respect of your time and poor May behind you, who has absolutely had it with us, thank you so much for your time. I love that you came on. Thank you. I learned so much.
Thank you for having me. It's been so wonderful to see you, Andy, and meet you, William, and just chat with y'all. Thank you so much for having me. This is
a great conversation. William,
to meet you.
Thank you.
This is an epic conversation. I learned a ton.
I still want to be. Oh, what's next for Lexi? Are you going to space?
Me?
Are you an astronaut yet?
Well, don't tell anyone, but my plan is to hitch a ride on the next New Glenn launch. I'm going to crawl in there and just kind of snuggle up.
Speaking of security, she's going to go in she's going to go in somebody's suitcase.
Yeah, I'm going to launch. No, I love my job. I'm having such a great time. It is so hard. I'm actually moving into a slightly different role, still integration. That's about all I can say, but it'll be same rocket, similar stuff. But we are eventually probably going to look to expand our team a little bit. So if anyone out there wants to move to Seattle, keep an eye on the website.
I know I could have looked this up, but is your launch schedule public? Like, do we know when the next launch is around?
I think our CEO has announced. What did he say? I can only repeat what he said.
Yeah,
I'm sorry.
I know. I should have looked it up and not asked you. Sorry.
No, it's okay.
I'm looking forward to
I know what it is, but I am. Yeah.
And the likelihood of it getting pushed out. I mean, that's just space, right? Like you can't control weather and all that stuff.
Yeah, I mean, sometimes we'll scrub because of weather and stuff like that. But he said, Dave Limp, our CEO, has publicly said that we will launch New Glenn no later than August. That is the public thing that he has said. So I can
this year. Okay. So we should see another launch this year, maybe. Wow. That's amazing. And they won't tell us like what's in the payload or anything. That's all like on the DL and
sometimes they'll say it.
Yeah.
Sometimes they won't.
I'll look it up. It's not fair to ask you, but I'm fascinated.
No, it's fine.
Yeah.
It's fine. Yeah, I'm sorry. I wish I could.
I'm super excited for the Mars stuff.
Well, I can say this. We're very focused on the moon right now. You can look up some public stuff about our relationship with NASA and stuff like that. So, keep your eyes out.
Go to the moon. Lex, thank you so much. William, always a pleasure. For all things Art of NetEng, you can check out our Linktree at Linktree/Art of NetEng. Check out the Discord server. It's all about the journey. There's a bunch of wonderful folks in there studying, doing things, talking about cool stuff. I didn't have a community in the beginning, and it was a hard slog. And the people around me were telling me I was wasting my time, money, and effort studying for the CCNA. Turns out that wasn't true. And then I found a community of like-minded people who were like, You're doing the thing. This is great. Don't give up. And it's really made all the difference in the world. It's been a much more pleasant journey finding my people, including these two wonderful people who have joined us on this episode. So thank you so much. This was amazing. And we'll catch you next time on the Art of Network Engineering podcasts.
Hey folks, if you like what you heard today, please subscribe to our podcast in your favorite podcatcher. You can find us on socials at Art of NetEng, and you can visit linktree/Art of NetEng for links to all of our content, including the A1 merch store and our virtual community on Discord called It's All About the Journey. You can see our pretty faces on our YouTube channel named The Art of Network Engineering. That's youtube.com/Art of NetEng. Thanks for listening.